Hello and welcome to this video lesson. In this video we will be looking at the basics of nomenclature in chemistry. Let's start off with a simplified version of a periodic table. It doesn't have all of the elements, but it has some of the ones that we need, and there are more, and we might need a separate periodic table, but this one has some of the important ones. In this periodic table, you can see that we have everything in groups 1, 2, 3, 4, 5, 6, 7, all the way to 8. And we also have some transition elements, and these transition elements have multiple different valences. So the importance of the location of an element within the periodic table, just to review this really quickly, if an element, for example, is located in the second group, then it will have two valence electrons. So the magnesium here, for example, if I were to draw its Lewis dot diagram, it will have two different electrons in its outer shell, and that's kind of what it looks like. And if I were looking at something such as chlorine, it will have 1, 2, 3, 4. It is in the seventh group, 5, 6, and 7. So it will have 7 valence electrons just like this. So in order for the magnesium to become stable, it will need to either gain 6 electrons in order to fulfill its 8 electrons in this shell, or lose 2 electrons. And the easier one is for it to lose 2 electrons. And when you lose 2 electrons, you get a positive charge of 2. And for the chlorine, it also has two options. It can lose 7 electrons and become positive 7 charge, or it can gain an electron, and that's the easier one. And that's what it does. It will lose an electron and it will have a charge of -1. So let's look at some of these ideas. So we're going to start off with the idea of ionic bonding. And to do that, we're going to fill out this chart, and I'm going to do about 2 or 3 examples, and then I'll let you folks try the rest of them. And instead of type of element, which is talking whether it's metal, non-metal, and so on, I'm just going to label this as either a cation, anion, or neither. And in order to fill this out, you need to know whether the object, when it fulfills its outer shell, does it become positively charged or negatively charged? And you can see that magnesium, let's actually start with magnesium. It is located in group 2, so we can label that as group 2. I'll use purple. The number of electron in its valence shell, so that's 2. Electron gain or loss, so it's going to gain 2 is it gaining electron or losing electron? In this case, it has to lose 2 electrons in order to become positively charged. Number of electrons transferred, there's going to be 2. Charge on the ion is going to be +2, and therefore it becomes a cation. Remember, the T is kind of like a plus, and that would mean that it has become positively charged. Now let's look at chlorine, which is located in group 7. And we got number of electrons in outer shell, well, 7. And in order to become stable, it needs to gain an electron. So it needs to gain 1 electron. And when it does, it becomes -1 charge, and because it becomes negatively charged, it's an anion. So negative. The letter that goes before the ion kind of indicates whether it's positively charged or negatively charged. And in this case, it's the N is for negative, and T is kind of like, looks like a positive, so it's a positive. Now, let's imagine that we got a magnesium here and we got a chlorine here. And what ends up happening if you have one magnesium, I'll draw these separately, Mg with 2 valence electron, and there's a chlorine about 1, 2, 3, 4, 5, 6, 7, and there's another one over here 1, 2, 3, 4, 5, 6, 7. What ends up happening is that this electron kind of goes here to fulfill the outer shell there, and one goes here to fulfill that outer shell. And what we'll end up getting is a magnesium with a positive 2 charge, and we will have chlorines with a negative 1 charge. And whenever you have positive and negative charges close to each other, well, whether they're far apart or closer, the closer they are, the stronger the force, you will have an electromagnetic force between them. If you have positive and negative, they will attract each other, and you will end up getting this happy ionic compound, which has one magnesium, which is positively charged, and two chlorines that are really close to it. The chemical formula for this then has to include one magnesium and two chlorines. And to write the two chlorines, we write it as a subscript like this. And you can, basically, we know the subscript for the magnesium is just 1 here. And we don't actually write the 1 when we're writing the chemical formula. Now, a shortcut of figuring out how to write the chemical formula when you have different cations combining with anions to form an ionic compound is to write the two separately. You always write the cation first and then the anion. And for the cation, the charge is 2 plus, and the chlorine is -1 or 1 minus. You can write it in any form, it doesn't actually matter. And you do this shortcut. Obviously, understanding it has to do with figuring out how many chlorines are attached to the magnesium. But once you understand that concept well, you can use a shortcut and just do a crisscross like this, keeping both of the charges and just leaving the value as a positive. And then the subscript for the magnesium becomes 1. And the one for chlorine becomes 2. And you don't include the one when you write the equation, so it just becomes MgCl2, and that is how you use a shortcut to write the chemical formula for an ionic compound. Now, how do we name these ionic compounds? Well, we always start with the cation first. So we write the name of the cation as it is, and we don't care about the number of them. So I'm just going to write magnesium. And for the anion, what I'm going to do, I'm going to start writing it out. And I would usually write chlorine here, but instead of the chlorine at the very end, what I'm going to do is I'm going to switch it to "ide", and I'm going to write it as magnesium chloride, and that is the name of this ionic compound. So basically what you would do is you would take the cation and you would write it first, and that would be the first thing, and you wouldn't change anything. And for the chlorine, instead of writing it as chlorine, I'm going to write chloride. And that's what we usually do. The anion is just switched at the very end, and we add the I to it. You may ask, how do we know how to write these? And after doing a few practice questions, you really will get a good idea about what all of the anions are called. But I will add the common ones here so you can have access to it. So I'm going to just pause the video, write them down, and then you can always refer back to them. Here I have added the common anions and how their ending would look like if it had if it combined with a cation to form an ionic compound. So you can look at those, and again, after doing a few examples like this, it just becomes second nature. So for this table, you can fill it out. I'm going to pause the video, just fill it out so you can pause the video, try it out on your own. It'll be good practice, and then just check your answers. So I'm going to pause, you pause, and then come back and check your answer. Alright, I have now added the elements in there, or just I fill out the chart here. So you can check your answers. Just remember that anything that has 4 can gain or lose that many electrons, so it could become positive or negative, and usually anything in groups 5 to 7 usually would gain an electron and become an anion, and anything in groups 1, 2, and 3 often lose their electrons and they become positively charged. Alright, here are some examples that you can try, and I'll go over some of them, and then I'll leave you to try them out, and then you can check your answers. And the ones that I'll go over are maybe the more challenging ones. I don't think they're that challenging, but let's go through these two. We're going to go over this one first, magnesium and sulfur. And the way to do this, we have to look at where they are within which group they belong to, and magnesium is in group 2, meaning that it will have a positive 2 charge, and sulfur is in group it would be in group 6, so it will have 2 negative charge. And we would have to, in order to figure out the chemical equation, we would do the crisscross, and we would get Mg2S2. But whenever you're writing these, if you do get something that can be simplified, like this is a ratio of 2 to 2, and this can be simplified to a ratio of 1 to 1. So you would go and you would write it like this. You don't even have to write all these steps, and this just simplifies to MgS. And that would mean that the ratio is just 1 to 1 between the magnesium cation and the sulfur anion. And then what we do in terms of the naming is going to be magnesium sulfide. Instead of writing sulfur, we write sulfide. And that's it. Let's do another one. We got Na, which is sodium. That's in group 1. So it's going to have positive 1. I'll write it like this. It doesn't actually matter whether you write the plus first or after. And the other one is P for phosphorus. And phosphorus is going to be in group, thinking 5. So P is 5. So 3 negative, or negative 3. And you do the same thing. You bring them, or you crisscross them, meaning that you will need 3. You will need 3 sodium ions to combine with the phosphorus there. So we're going to have Na3P. And the name for this is just going to be the cation, which is the sodium. And instead of phosphorus, I'm just going to write phosphide. And that's it. You can pause the video, try the rest of them, and then I will write the answers in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, so now you can check your answers. You can pause the video, check it, and now we're going to move to the next section, which is naming ionic compounds with transition metals. So I'm going to move this up. And here's just the rules, so you can use the rules, and we'll go over some of the examples, and then you can try them out. What we usually do with these ones is we state the name of the first compound, and we use Roman numerals to denote the charge of the transition metal, and we do that in bracket. The chemical formula depends on the charge of the ions. So, for example, here we got Cr, and I know that Cr isn't in our simplified table, at least I don't think it is. So, Cr stands for chromium. And chromium is spelled CHROMIOM. And the charge of this one is +2. And this is a transition metal. It's within the section which is the transition metal, and they have multiple valence. So we can go, for this one it has a charge of 2, so we use brackets and we do a Roman numeral for 2, which is just 2 vertical lines. And the rest of the naming is same as before. So Cl is for chlorine, so this is going to be chloride. The chemical formula for this is going to be same as before. So we got Cr with positive 2 charge, chlorine with 1 negative. We do the crisscross, and we will get Cr, and we need 2 chlorines in order for this to work. So that's the chemical formula. All right, let's do a few more here. We got Fe, which stands for iron. So I'm going to write that down. So for the name, it's going to be iron. The charge is 2. And we got chloride. And then for the chemical formula, again, it's the same idea. We got 2 plus, we got Cl, which is 1 minus, crisscross, and you will get Fe 1 and Cl2. So that's how we go. And if that's how we do it. And the next one again is iron. And you can try these out, by the way, folks. You can pause the video and actually try everything on your own and then check the answers. I haven't done any examples here yet or here, so you can either try it out first and then check out the answer, or you can just wait and get to it. I highly recommend that you try it on your own. So iron has a charge of 3 here, so 3, and this is going to be oxide. And it's the same idea. We got Fe 3 plus, oxygen 2 minus, and this would be Fe 2 oxygen 3. The next one is copper 1 chloride. So if we have the name and we're trying to find everything else, then I would suggest that you write the 2 different ones first. So copper is Cu, chloride is Cl, and the charge of copper here is +1. And chlorine, you can figure that out because it's in group 7. That's -1. And I know this is +1 because of this. And if that's the case, the formula just becomes copper and chlorine. That's it. And what is causing this? That's, sorry, this is 1 plus, and chlorine is also 1 minus. So I want to make sure that I write this well. So I'll write it as 1 plus. Now you could also have the formula, and then you got to figure out everything else. And I think that's usually the most challenging one. And the way you have to do, you can't just go ahead and say this is copper 1 oxide. First, you have to write them separately, like this. And you would have to write the charges. So you can also just do that here, copper and oxygen. And oxygen, you know that it has a charge of 2 negative. And you know that when, this is the hard part, you know that we have to do the crisscross, and then you know that at the very end, this is simplifying to 1 to 1, and that is the tricky part. So at the end, this is going to end up being 1, 1, meaning that initially what came down should have been 2. If this is 2 initially, when it comes down, sorry, I'm going to write this as 2. I'm just going to erase these and say that it's going to come down like this, and then simplify to copper 1, oxygen 1, because this value that's coming in for sure is 2, and later on what we're getting is copper oxide like this, copper 2 oxide here. And yeah, so this 2 that came down came here, and in order for this to simplify to 1, this should have also been 2. And if this was 2, that would mean that that's a positive 2 charge. So you can put those values in. The copper is going to be 2 plus, oxygen is going to be 2 minus for this to work, and you're going to have copper 2 oxide. Okay, we're getting there. The next one here, CrCl2, so CrCl2. And when you have something like this, you know the charge of chlorine is -1, and you have to figure out the charge of this one now. Usually you would have to do this in order to get there. So we know that the 1 actually came down as a 1 because we don't see anything here. So that would mean that this has to be a 2 plus. There's nothing else that would really work. So this would mean that we got a chromium of 2 plus. We got chlorine of -1 or 1 minus. And this will become chromium 2 chloride. And just to be consistent here, I'm going to write this as 1 plus. Finally, for the last one, we got this, and we get a 2 minus, crisscross. We get the 2 and we get the 3, so we get Cr2O3. And in terms of the naming is chromium 3 oxide. And this is how we name ionic compounds that have transition metals. The next thing we're going to talk about is naming compound with polyatomic ions. And polyatomic ions are basically ions which are composed of 2 or more atoms. These are some of the common polyatomic ions that I want you folks to remember. And I pretty much want you folks to I will call it, instead of memorization, deep learning. These are some of the very common polyatomics that polyatomic ions that you're going to be using in chemistry. And these are the symbols for them. These are some of the examples of the different names that you can use them in. And this is the polyatomic name. So for example, nitrate has a charge of -1, and its symbol is NO3. And ideally, as somebody who's going to take chemistry, I would really memorize these with their symbols and probably their charges as well, at least for 1, 2, 3, 4, 5, 6, 7, these 7. And I think later on, depending on which chemistry course you take, you might learn more complex situations. So what happens when the charges or number of oxygens change. So those ideas are also something that you may have to learn later. But for now, let's kind of talk about how we can use these to name different compounds. So let's say we have a sodium and hydroxide that are going to be combined. So sodium's is Na, and hydroxide, oh, that's something new. We have to go and look for it over here. And hydroxide is over here. It's OH, and it has a charge of -1. So I'll write it like this. And Na is in group 1, so it will have charge of +1. And in order to figure out the equation, we use what we did last time. Basically, it's a crisscross like this, and we're left with NaOH. Now, if the subscript for both of them is 1, you can just leave this as the formula. So I'm just going to write it as NaOH. And the name for this is going to be sodium hydroxide. So the first one, this is the cation, it's just sodium here, just like we named it before. And the second one is just the name of the polyatomic ion here, which is hydroxide. Let's look at the next one. We got calcium here, so we got Ca with +2, and we got HCO3 with -1, which is the hydrogen carbonate. And the same idea applies. We do the crisscross, and we get Ca gets the 1, and HCO3 here gets the 2. Now, if you were to put the 2 here, without any brackets, it seems like the calcium, you have one calcium, you have one hydrogen, one carbon, three oxygens. Actually, not three oxygens, you have 2 times 3, which is 6. But you only have one hydrogen, carbon, and oxygen. That's not the case. You have to put a bracket here to indicate that there's 2 of hydrogen carbonates and not just oxygen that is being multiplied by 2. So this bracket kind of helps separate, and not separate, but kind of group all of this together, and that's what you need to do. This is CaHCO3, 2. And the name for this is going to be calcium hydrogen carbonate. So not too bad. Then we're going to do magnesium and sulfate. So magnesium gets the 2 plus, and I'm looking for sulfate here, and sulfate is SO4 with 2 negative. Based on our table, we'll do the same thing, and we get the 2 and 2, and the 2 and 2 are going to simplify to just 1, 1. So I'm going to write this as MgSO4, and I don't have to actually put this in bracket because there's just 1 to 1 ratio here. The name for this is magnesium sulfate. Easy. All right, next one, we got a potassium. So I can even start by writing potassium here. Potassium. And the other one is PO4. So looking at my table, PO4 is phosphate. So I'll just write it out, phosphate. And to figure out the equation, the charges are here, so you can see you get the negative and you get -3, and you get the +1. Do the crisscross, and you will get K3PO4. Now, you don't have to put this in bracket over here because it's just one of them. And if it's just one, you don't actually put the bracket. Next, we got lithium and carbonate. So this is going to be named lithium carbonates. And in terms of the equation, lithium is going to be Li with a +1 charge, and carbonate is going to be CO3 with 2 negative charge. And do the crisscross, and you will get Li2CO3. And this is just one of them, so we don't have to include the brackets there. Now, for the next one, we got NH4, which is a positive charge. So this is, I want to cover this one with you. You can see if it's NH4 positive, it's a cation. And then you got the Cl, which is an anion. So we have to name it using the same naming convention as we did before, where for the anion, we add the "ide" at the end. So just for the name itself, we got ammonium. So we'll start with that. That's our cation. So we got ammonium. And the Cl is chloride. It's not, we don't write it as chlorine here when we're writing an ionic compound. The anion there just gets the "ide," unless it's a polyatomic, then we will have to use their name. And in terms of the symbol here, it's going to be NH4, and we got +1 and -1, so it's going to just be NH4Cl, and we don't have to include brackets here because they both have a subscript of 1. Now, why don't you try the next 3 on your own, and you can pause the video and come back, and I will write the answers in 5, 4, 3, 2, 1. And now you can check your answers here. Just for the very last one over here, NH4, sorry, we get ammonium here, which is NH4. We got carbonate, which is CO3 -2. So if you do the crisscross, you get the 2 here. So I put the brackets in this one because it's got a subscript of 2, but the CO3 doesn't have any, so I didn't include it. And in terms of the name, just because CO3 is a polyatomic ion, we just leave it as carbonate and we don't write it as carbonites or natide or something like that. So that's it. Finally, let's talk about naming covalent compounds, and this one is a little bit easier than the rest of them, I think. And the way we do this is the first element in the formula is named first, and the full element's name is used. The second element is named as though it was an anion, so we got a root and we got "ide" at the end. Prefixes are used to denote the number of atoms present. The prefix mono is never used for the very first element. So in terms of summary, to use these set of rules, the compound must be a molecular or covalent bond. So it needs to be a molecule, or it needs to have a covalent bond. It needs to be a non-metal plus a non-metal, or a metalloid. The rules are that you name the first element first, and the second one always ends with "ide." Use the prefixes to show how many of each atom is present in the molecule. And there's a few special rules. So the mono you never use for the first element. And for oxygen, you don't include the O and the A in the prefix. So for example, if you got carbon monoxide, you write it as carbon monoxide instead of carbon monoxide. So you don't include the O again in there. And do not reduce the subscript. So usually in the last one when we were doing the ionic compounds, we reduced the subscript. So if we had, let's say if we had Mg and O, so if we had magnesium oxide, the subscript would be 2,2 and we would change it to 1,1 and not include it. In this case, we don't do that with these ones. We just use the prefixes. The prefixes are shown here. So for 1 we use mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Let's do this. So first one we got nitrogen trichloride. So nitrogen symbol is N. Since it's the first element and we don't have any prefix for it, it just means it's N. And trichloride, so chloride is Cl, and there's 3 of them, and that's our name. For the next one here, we got S, which is sulfur. So since it's the first one and it's just mono, we don't really write anything else. We'll just include it as sulfur. And we got 3 oxygens, so it's going to be trioxide. For the next one, I'm going to change the name to this. This should be tetra boron monocarbide, and that would mean that you're going to have 4 of boron and monocarbide, so just the C. And then we got 2 nitrogens, so the prefix for 2 is dinitrogen sulfide. Next one we got dinitrogen trioxide, so that would mean we got 2 nitrogens and we got 3 oxygens. Next one is phosphorus, and we got 3 hydrogens, so it's trihydride. And you just continue that way. So we got phosphorus pentafluoride, so phosphorus is P, penta is 5, so you would go fluoride is comes from fluorine, so there's 5 of them. And then we got boron trifluoride. So basically for all of them, you're just looking at how many of each you have. and you go based on that. Methane is one that you can write in different ways. It's carbon and it's got 4 hydrogens. So it's CH4, the symbol for it, and it's a good one to also learn to have a deep learning of, or to kind of have a good understanding of, because you're going to be using it a lot. So that's CH4. So to name this, the C is just carbon, and hydrogen, there's 4 of them, so you have to use tetra. So another name for it is carbon tetrahydride, and that's another way to do it. And here we got P2Br4. So we got phosphorus, we got 2 of them, so I have to use diphosphorus. And I have 4, so I have to use tetra, and this is bromide. And you can try the rest. There's a few more left in here. Well, many more left. Try it out, and I will write the answer in 5. Oh, actually, you pause the video, and then I'll write the answer in 5, 4, 3, 2, 1. All right, and here it is. You can check your answers there. Remember that these are all forming covalent bonds, and if they are stable, then you can also just use the Lewis dot diagrams to draw the Lewis structure diagram from it. So let's do an example, so just so that you can see how that works. Let's do the first one. It doesn't really matter which one we do. I'll do this one, and it's NCl3. So nitrogen, if I were to draw its Lewis dot diagram, it has nitrogen, and it's in group 5. So it will have 1, 2, 3, 4, 5 valence electrons. And chlorine has 1, 2, 3, 4, 5, 6, 7. And there's 3 of them. And basically what will end up happening is that this chlorine comes here, another chlorine, so to share electrons here, and another chlorine will come and stick here, and another chlorine will come here. So I'll draw that using the Lewis dot diagram, so you kind of see how they will look like when they're all combined. And I'll use different colors so you can see the chlorine. This is Cl. There's another Cl right here. 1, 2, 3, 4, 5, 6, sharing an electron here. Oh, sorry, I did want to use different. Actually, it's okay to use red there. And I'm going to use another Cl here. 1, 2, 3, 4, 5, 6. And you can see that there's a set of shared electrons in here. There's a set here. There's a set here. So if you were to draw the structure diagram, or the Lewis structure diagram, it will look more like this. You have the N. For the bonds, we will, instead of the shared electrons, we will show it using a stick like this, and we will have the chlorine, 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 and the nitrogen has 2 valence electrons like this. Now chlorine is left with the 6. And you can check each individual ones and make sure that they all have 8 and are happy. So you can see that chlorine has 1, 2, 3, 4, 5, 6, and each stick represents 2, 8. So the chlorine is happy. This one the same, this one the same. And nitrogen has 1, 2, 3, 4, 5, 6, 7, and 8. So they're all sharing electrons. In general, all of these, in terms of their charge, has a net charge of 0, and they're all happy because they all have a filled in filled in outer shell and net charge of 0, and therefore they're very stable with very strong covalent bonds. And this concludes this video, and I hope that it was helpful in teaching you how to name and write the chemical formulas for ionic compounds and molecules that have covalent bonds. Have a wonderful day.